don't get 3 pieces.
We'll finish 1-4 today. 1-4, my math lab homework will be due tomorrow. If you ever need to come get help from me during flex, you should know that the only time I can actually help is third flex, which is y'all's lunch, isn't it?
Yes.
Yeah.
So you can either come in here and eat lunch in here and get help, or you can come in here and get help during the second flex. I eat my lunch in here by myself anyway, so some people do like hang in during lunch because they prefer not to be in the cafeteria. So I guess your opportunities for help would be second or third. But if you're coming second, I need you to text me in advance so that I know to be in here, because sometimes I go get sweet tea from the cafeteria, or if I forget my lunch, I run to get something. So second or third if you need help. On the horizon is the Chapter 1 exam, and the plan is next Wednesday. I think we said. I think.
Sounds
It's
right.
gonna freeze. It's gonna crash.
They did.
I think the plan is next Wednesday, because I think that day that I was trying to show you on Friday why I needed to teach on Friday. I was lining it up. We're trying to get the Chapter 2 exam before fall break.
The Friday.
The Friday before fall break. So in order to do that, the Chapter 1 exam needs to be next week. And I'm shooting for Wednesday. You should not have to take as much time before the exam on that exam day, because you already know now the procedure. You know, stuff at the front, cell phones out, and then you exchange them. We reset the calculator. The exam will be on my math lab, so I don't have to pass any papers out that prevent you from starting it. Yeah, it was next Wednesday. We're on 1-4. We're going to finish 1-4. Then we've got 1-5, 1-6, and 9-1. We have 3 sections left between the 12th and, say, the 18th. And then review, exam. Then we start Chapter 2, and that gives us 2.5 weeks for Chapter 2, which is about what we need. Okay? Did you have a question? Okay. All right. What was your question?
It was like when that 1.30.
It was due last night. Yeah, because it was finished on Thursday. Now, if you haven't finished it, it will only deduct 10% from the questions you answered now. Which means the highest you can make is a 90. But if you had started it, and then you just have a few left, then you can actually make higher than that. It's just going to reduce. Yeah. All right, 1-4. Writing the equation of a line given the slope and the y-intercept, and then getting it in standard form. Writing the equation of a line from a graph, getting it in standard form. Writing the equation from a line given the slope and a point. So you had to find B, then you write the equation, then you get it in standard form, which brings us to point slope form. You do get the freedom of choice of picking a point when you reach this step. A lot of people panic and run. They don't know which point to pick. It doesn't matter which point you pick. They're both on the line. But I tend to pick the one with fewer negatives or nicer numbers. And that was it. That was Friday. All right, so we got to here. Yeah. Looking at parallel lines. First of all, remember that parallel lines means it's like railroad tracks. They never cross. You do have a couple of scenarios. You have strictly vertical lines as parallel. It would look like that. You have slanted lines as parallel. Notice what's the same in the parallel lines. is the same. Notice the 2x and the 2x. That's why they're parallel, because it's like saying that they're, they have the same rise over the same run, which is exactly why they're parallel. If you look at the third example, you'll see that the two lines definitely cross, so we would just simply say not parallel. Notice right here, these two lines are strictly vertical, right? Both of them. That is to say that any two vertical lines, doesn't matter where they are, any two vertical lines are by default parallel because they're both vertical, which makes sense. If they're strictly vertical, there's no slant at all, so it would be parallel to any other vertical line. The takeaway from this slide here is that parallel lines have the same slope. Slopes match in parallel lines. You should remember that from Algebra 2. I don't think parallel lines was taught in Algebra 1. I could be wrong, but you should remember that from Algebra 2 for sure. And then this slide is letting you know what the visual is for perpendicular lines. First of all, you should know that the shortcut notation for perpendicular is an upside down capital T, and it helps to draw the little square box to let you know. It helps to draw the little square box to let you know that the angle between any two perpendicular lines measures what? 90. Every time, all day, every day. So it helps to draw the box so you remember there's an angle there that you know by default. Here are three visuals. The first example is when you have a vertical and a horizontal. Ironically, I wrote it backwards, but that's okay. A horizontal and a vertical line, no matter where they fall, will always be perpendicular to each other. Any horizontal and vertical line on the same graph are by default perpendicular, and that's because they are complete opposites. Where this has a slope of 0, this has a slope where 0 is in the bottom of the fraction, making it undefined. They're opposites. If you look at the example in the middle, when you first look at it, you might say, okay, that might be perpendicular, might not be. What can I look at to answer definitively whether it is or not? The slope. This is a slope of 3/4. This is a slope of -3. They are not perpendicular, so we want to write above it. Here's an example of not perpendicular. And then the last example is, if we look at it, we have a slope -1/2 and +2. I'm going to say line 1. Line 1 is -1/2. Line 2 is 2. You need to know that perpendicular lines have what's called a negated reciprocal slope, meaning there's two things going on here. They have to have opposite signs, and then the fraction has to be in reciprocal form. So if this is -1/2, this has to be +2/1, which it is. So these are called negated reciprocals. Negated doesn't mean make it negative, it means change the sign. Multiply by negative, which will change the sign. It's kind of like if you're in an argument with someone who's very negative, all they throw out is negative content. Well, if you negate it, you're multiplying it by a negative, which means it's going to change the sign. So it could result in positive depending on what it started as. So these are definitely perpendicular. So the takeaway here is that perpendicular lines have, and we don't have to write it again, but you can if you want to, a negated reciprocal slope. Or you can say opposite slopes. And what we mean by that is sine and fraction. The sine is opposite and the fraction's flipped. Now this fancy thing right here, you don't have to box this in. I just want to draw your attention to it for a second. Instead of saying, hey, make sure the sine is opposite and the fraction's flipped, we're college level. So they're saying that if you take the two slopes and multiply them together, you should get -1. So if you imagine if I had -1/2 times 2 multiplied straight across, I would get -2/2, which is -1. So this is, you don't have to do this because I personally see it easier to just check the sign and check the fraction. But if you wanted to know the college level math behind it, it's you multiply the slopes and you should get -1. That's the college level math. You don't have to do that though. You can just check the slopes. All right, go to the next slide. So now we're going to practice. Determine whether each of the following pairs of lines is parallel, perpendicular, or neither. So we have 3 parts here. If I say determine if it's parallel, perpendicular, or neither, I'm basically saying find the slope. Find the slope for all of them, which means it must be in what form? Must be in y equals mx plus b form. So you have some work to do for A, B, and C. And I'm just going to turn you loose because everybody should be able to get it in slope-intercept form. But I am going to copy the equations down. So get every one of those in slope-intercept form and then say whether they're parallel, perpendicular, or neither. When you moved these to be in slope-intercept form, did you get this?
Yes.
So remember what I said last week, when you need to divide by the number in front of y, you want to divide in an a la carte fashion so that you can reduce anything that is reducible. So this is, this is 5, this is -1/5, which would mean these two lines are perpendicular. I'm just going to do this. Perpendicular.
Is there a sign for parallel?
There is, and it is literally 2 giant L's.
Okay.
Like, I mean, that, I'm not kidding. This one, did you get that? That?
I can't really say anything. I'm not going to say anything. No.
Yes, ma'am.
It's all right. I'm ready. I'm ready. Oh, this would be at YouTube. You've been nice to me about it. This one's nice.
No, I'm not going to say anything.
It's only 1 away from the number of L's Alabama has.
No,
I'm just kidding.
I-
Tennessee can't say anything.
I know.
Okay?
I know.
They're
That's why I
struggling
wasn't-
Saturday.
That's why I said it.
It's terrible.
At least we didn't get blown out.
Awful
Yeah, no,
game.
see.
I suppose.
Maybe I should not say
Did you
that.
see the
Yeah, bro. But
well, one of her running backs from North Carolina State during that lightning break, he sat and drank 4 Diet Cokes and ate hot dogs.
But honestly though, when Nick Saban came in and like set the bar that
Who
high,
played North Carolina
like what do
State?
you expect, you know?
Notre Dame.
So
Notre Dame. It was Notre Dame. Notre Dame's running back.
well, and it's honestly it's like
Notre
pretty
Dame.
smart. And
Hey,
in the first
Notre
year,
Dame's running back drank
he
8
set that
Diet Coke
expectation.
and had
Watch,
4
it's
hot
gonna
dogs
happen.
in the
I'm
lightning
speaking
break of
for
their
15
game.
years.
Kirby's
Came
Smart is
out
gonna be
and
a
outran
top
everybody for a
30
touchdown
years.
for 25.
Yeah.
I mean,
How'd that face
that's
go?
a recording.
Better keep your dog out of the road.
I mean,
All right, look at this. Come right back here. I wanted to show you the second equation when you were manipulating 5 plus 2x equals negative y. Hope to solve it for y. Hopefully you didn't move stuff from the right to the left and y. You could. Now if you did that, I hope you did it in one swoop and then just recognized that all the signs change, right? Or you could, here's what I mean by this. You should have noticed y is already by itself. Okay, yes, it's on the wrong side of the equation, but it's already by itself. Well, because it's an equation, I can mirror it over here, and it's the same thing. That's a mirror image, right? You with me? As long as the left equals the right, I have not changed anything. This is still the original, and this is still the original. And then you should notice, oh, I'm going to multiply the whole thing by -1. And then focus on the number in front of x. You see that? So that's just a more intuitive way to manipulate that equation without having as much work involved. All right, so back. Here we go. So the slope's -2. -2, what'd you decide? Parallel. There's your symbol for parallel lines. And then the last one, did you come to y equals 2x plus 1? There was nothing to do here. I just moved the y to the other side. That one was already done. And then y equals -3x plus 4?
Yes.
Okay, so what can you say?
Neither.
This would be neither. No, there's not. You would just say neither. Alright. Write the equations of the lines that would be parallel and perpendicular. Okay, so now instead of saying whether they're parallel or perpendicular, they're actually giving you a line and then a point not on the line. You have to visualize this and saying find the equation of the line that would be parallel, then part 2, perpendicular to this line containing this point. This should ring a bell. Okay, let me give you a visual. You need a visual. They're saying, hey, here's a line. Then they're saying, here's a point. Right? Part A says find the equation of the line that will be parallel to this one, so train track, right? But passing through this point. So the only place for the train track would be here. With me?
Yes.
Part B is saying find the equation of the line that would be perpendicular to this one, but passing through this point. See that? That's part B. So wrap your mind around the visual. The line that they give us is the blue one. This is given. The point they give us is right here. Not that. That's not the real point. It's 2 negative. That's not bad. 2 negative 3. And we have to find the equation of purple and the equation of orange. You with me? You've already done this before. Last Friday, we also did this here. Oh,
You're on a different set this whole week.
it's crashing.
You're not on 1.4.
Don't act like I'm like a geriatric patient or something with dementia. He's like, I can't believe her. She didn't know that she was on a different side. It's all good. It's all good. All right, look right here. See this one? Remember this? You already did it, right? The difference is the similarity is I'm going to give you a point on your line, and then instead of a second point, I'm going to give you an equation. What do we need from that equation in order to write ours?
X and Y.
Slope. Thank you.
You're on a different slide. You're on a different tab.
Oh my God! That almost hit me. That could have cut me.
Hey, let's
Good
not
throw.
let's
Maybe
not
you should
throw
play
things
quarterback.
in class.
Oh my God!
I mean, I'm class.
Because I'm so manly.
What's going on?
You just said I could suit up as a quarterback. It's all right.
Sorry.
I played left field in softball. It's okay.
I'm sorry. I'm sorry.
Seriously.
I'm sorry.
All right. Should play first base.
I played first base.
I played first base. What? No. What'd you say? Okay, excuse me. He got the ball to their hands. They did not catch it. There's no excuse for D1 scholarship athletes not catching the ball that hits their hands. What is that? Over? And over? Oh, over and There's a lot of this. All right. So, no.
Oh,
yeah.
there you go.
So you've seen the visual. We have the line that they've given us. Then we have the point on our line. I say our line because the one we need to find. That's the point on the line we need to find. So let's compartmentalize our work here. Let's say part A asks for when it's parallel. Part B asks for when it's perpendicular, right? When it's parallel, be quiet. When it's parallel, what do you know about the slopes? So you might want to make a note to yourself, same, I'm going to put M for slope, same slope. When they're perpendicular, what do you know about the slopes? So we're going to say negated reciprocal. I really want you to use the vocab. Negated reciprocal slope, meaning opposite sign, switched fraction. So what do I need from the line that they gave me? I need the slope. We need M from here before we can ever try to find the other lines. So you've already practiced finding the slope because you just did it on the last slide in order to determine if two lines are parallel or perpendicular. So you're taking the equation that they give you. This is the given line, not the one we need. This is the given one that we're trying to calibrate our line too. Find the slope from that line. How do you find the slope?
Get
You
y
should
by
know
itself.
this.
Isolate y.
Get y by itself by putting it in slope-intercept form. Then you can read the slope. It'll be the coefficient of x. What'd you get for the slope? 1/4. Okay, I need you to understand that once you give the slope from the given line, you no longer need the given line. And it would help probably to strike through it so you don't accidentally try using it again. It's kind of like a, just get what you need and get out of there. And that's the slope. The slope is 1/4. So I'm done with this. I'm slashing through it to tell me, okay, you don't need anything else from it. But now we need to manipulate the slope, or not, depending on, we're finding what? Parallel. The slope of this line was 1/4, so this is a little redundant, but I'm going to write it anyways. So the slope of my parallel line, notice what I put there to remind me this is the parallel line, would then be, it's still 1/4. You don't have to write that. I'm just letting you know where my thought process was. Pull the slope from it. If it's parallel, it's unchanged. If it's perpendicular, so the slope was 1/4, but my perpendicular one would be -4, technically over 1. So you see the difference? When it's parallel, you don't manipulate the slope. When it's perpendicular, you will have to change it. All right, so now you finish this problem exactly like the slide that I was directed to show you from Friday, and that was this one. Nope, this one, where you had a point, and you found the slope, and then you used point slope to get the equation. That's how you finish this. You have a given point, it has to pass through. You know the slope, so you're going to plug it into point slope form. So I'm going to go back, and I'm going to copy in, can't really see the green. Let me try and change it to dark green. All right, so here's the point slope form equation. And then so that you understand where I get these numbers, the point they told me it has to pass through is 2, -3. So 2 is your x, -3 is your y, and 1/4 is your m. Sub 1, I should type sub 1. Remember, it only goes in place of the sub 1s. So you're plugging x sub 1, y sub 1, and m into point slope form, and you're cleaning it up. Remember, when you're writing the equation of the line, the y and the x in there stay there. They stay there as part of the equation. You don't plug anything in to the plane y, plane x. slope-intercept form. You could get it in standard form if you want to keep practicing, but for this right here, I don't mind you going to slope-intercept form. Oh, yeah, it would reduce. Yeah, you're fine. Now, in my math lab, you would need to read the little blue suggestion because sometimes they want fractions, sometimes they want decimals. I think in my math, in fact, I'll change it to 7/2. I think in my math lab, they do prefer fractions, from what I recall. So you would not be expected to do that in your head. You would just think to yourself, well, actually you could do it in your head because this is pretty. This is -1/2 and you're subtracting 3, so that's the same sign, so that'd be -3.5. As a fraction, that's 7/2. If you can't do that in your head, then you would go to your calculator and type -1/2 minus 3. Then you would hit math frac, and it'll spit it out as 7/2. All right, I want you to finish this one right here. We already started it. We started it by saying if we're finding the perpendicular, we need the negated reciprocal, and of what? It would be of the 1/4 that we pulled from the equation we only needed the slope from. So the negated reciprocal would be -4. Because it's the opposite sign, you take the fraction and you flip it. So now we have our point, 2 -3, that's still your x sub 1, y sub 1. Then you have your slope. Did you get that? Okay, so what you've just done is found the equation of the line that would pass through the point 2, -3 and be parallel to the given line. And then this one would be perpendicular to the given line. The only purpose of this given line is to get the slope. That's the only purpose. Once you get the slope, notice I slashed through it so that I wouldn't try to accidentally use it again, because the only thing we need from it is the slope. Doesn't matter what the y-intercept is. In fact, you didn't even have to divide the 4 under the 20 if you just wanted to know the slope. All right, go to the next slide. This slide is summarizing all of the info that we've talked about. It's kind of like a good one-stop shop if you need a refresher. The takeaway on this slide is something we've already talked about, but I want to put it on the slide because some people, they get caught up in the horizontal and the vertical lines and they forget this simple fact. Every vertical line is perpendicular to any horizontal line. Every perpendicular or vertical line is perpendicular to any given horizontal line. remember we talked on Friday. Was it Friday? No, it might have been Thursday. HOI-VUX. HOI-VUX is the acronym to help you remember that horizontal lines have a zero slope, and they are y equals the y-intercept. Vertical lines have an undefined slope, and they are x equals the x-intercept. We did that Thursday. We wrote it somewhere on your notes on Thursday. So that would be 1-3. That was the 1-3 notes. It's in there. Because usually I try to say be careful when you're pronouncing the VUX part, so you don't accidentally say something inappropriate. But my kid was here that day, so I didn't want to draw attention to it. Okay, the next part, you need a calculator. You need a graphing calculator. You can either use, well, no, I can't tell you how to do it on Desmos, so you need mine. Oh, my hair touched the floor. There you go. Yeah, all right. So if you look right here, page 51 in your textbook, we are looking at curve fitting regressions. You need your calculator. Your calculator is going to be your best friend for this. I'm not expecting you to do this in your head or by hand. It is by the lovely folks at TI Instruments. Curve fitting would be looking at a plot of data and asking yourself what type of graph would probably go through those data points as best as possible. So the easiest example would be linear. If you think of, like if you had a set of data kind of like that, you would look at it and you'd say, okay, I bet I could draw a line like right through it and it would hit as many as possible, right? That's called linear regression. But we are moving up from linear regression. We also have quadratic regression, we have cubic regression, we have exponential regression. You can eyeball, meaning you just look at it and you decide, okay, it looks like that would be a line, it looks like that would be a quadratic. You can do the eyeball test, but obviously we're going to get to where we're actually doing math. So go to the next slide. If you're looking at this right here, cost of a 30-second Super Bowl commercial. This data is from 2010 to 2015, and then it's asking estimate for 2018. So obviously we passed 2018, so I'd be curious to know how accurate it was. But if you're looking at it, the cost of a 30-second Super Bowl commercial has increased $1.6 million from 2010 to 2015. Model, what is it, the data? Yeah, in the table on page 52, I've copied the table for you so you don't have to go to your book. It says with a linear function, this is important, they're telling you straight up, even though you should be able to look and see a line, they're saying to use a linear function, then estimate the cost of 30-second commercial in 2018. So the purpose of this is like if you're running some type of company that wants that advertising spot during the Super Bowl, you might need to be able to manage the funds in order to be able to afford that Super Bowl spot 3 years from now. Because the spot, I don't know how fast those spots fill up. So if you're looking at this, I give you, can you turn to the next page so I can see what I did? I did, okay. So if you're looking at this, you can see that we have the year, and we're going to represent our baseline year 2010 as x equals 0, meaning our starting year. So then 1 year from that would be x equals 1. You understand that, how they're getting this? Okay, so this is your baseline year. right here, x is 0. So in 2015, that would be 5 years after 2010, x would be 5. This is the cost of the commercials, 30-second commercials. Here's what it looks like on a stat plot, okay? And then they're telling you to use a linear regression. We're going to do this on the next slide. Go to the next slide. What is linear regression? It generates the line of best fit that serves as a predictor for future values. The first thing you've got to do, you're going to have to know these steps. You're going to have to practice this before the Chapter 1 exam. There will be one of these on the exam. You've got to know how to do this. You cannot say, Ms. Holcombe, I don't know how to do the steps for getting linear regression. I cannot tell you, okay? So I don't know if you need to highlight this slide, put a Post-it note, study this, practice this, memorize this, something. I put all of the steps on here in full detail so you don't have to write them down. All you have to do is let's practice it right now on a calculator. The first thing you have to do, and I'll tell you this before we take that exam, is you've got to turn your diagnostics on. So you're going to hit the second button. There's catalog right here. This is the ongoing features in the calculator. I'll tell you this before the exam. You don't have to memorize this part. We want to get down to where it says diagnostics. It is in alphabetical order. You can hit the button with a D above it, and it will jump to the D options. And then you can scroll till you see diagnostics on. And then we're going to hit enter twice. So now your stat diagnostics have been turned on. By default, they turn off. The day of the exam, I'll make you clear your calculators, and then I will say, okay, do this, this, and this, and then show me that screen so I can make sure you're set up. The rest of it you got to have memorized. Okay, so now what we want to do is enter the data in the calculator. Okay, we're going to go to stat. Should be pretty intuitive at first. Okay. Does anyone else need to get a calculator? So it's pretty intuitive. You're going to hit the stat button. It's going to say, okay, what do you want to do? Edit would be where we want to put the information in the calculator. So we're going to say edit. Mine's still in there from last year. Yours would be clear, right? Yours should be clear. Let me clear it. Hold on. It's fine. Don't worry about mine. Starts with L3. I literally, when I cleared it, I literally deleted the column instead of clearing, but it's fine. Hit stat. Well, after you turn diagnostics on, turn that on. You have it on? Okay, hit stat, hit edit. It's underneath delete.
Yeah, I found it. Thank you.
I'm just trying to help you out. Trying to be a good friend.
Okay, we're going to enter the data. Our L1 is our X values. Our L2 is the Y values, which are the cost of the commercials. So I put the data on your paper. I don't know if you can read it. Did it print okay? Okay, well then go to the last slide. Go to the last slide, and you can copy the data from right there, the last one, not the next one. So we got 0 to 5, right? Now to enter the millions, we are not entering million. We're just going to enter the, like 1.2 million, 3.1 million, whatever those numbers are. Now I got to actually go back because I can't read it. 2.9. So far, all we've done is hit stat edit and we've inserted the points. That should be what is it? User friendly, self-explanatory. Not a lot of thinking involved there. You're just putting the data in the calculator. Now from here you can go straight to the next step, but I want you to see it as a scatter plot. So I'm going to hit zoom. There should be a stat feature. Number 9, zoom stat. Check let's go to stat plot. Hit second, stat plot. You gotta turn them on. Turn it on. On. Everything's fine. I put my X's in L1, my Y's are in L2. You want to leave it as a dot plot. We don't want anything else. Second, I did it. Y equals, and then it's going to be right there. Hit enter to tell it to turn on. Once you specify, hey, turn on, and then what do you want out of it, you're going to hit zoom stat. Zoom stat. Your stats might be off. Hit second, Y equals, and see if your stats are on or off. If they're off, you got to turn them on. You would select it. So I'll go back. You'll hit Y equals, second Y equals. See, mine's on, but let's pretend like it was off. I would hit enter, and I change it to on. I'm going to show you. So zoom stats. So there's the dot plot, right? By the way, what we just did is listed right here where it says view the scatter plot. Those are the steps to do that. You do the second, Y equals, that's stat plot. You turn plots on, and then you hit zoom 9 because that's zoom stat. So we just did that. Now what we're going to do is calculate the linear regression. We're going to tell the calculator, hey, I need you to take all those points I just gave you, and I want you to find the line of best fit and tell me what you get. So this calculate the linear regression is telling you to do that. So go into your calculator. We're going to say stat button. Now edit is when you want to change something. We're ready to calculate. So you're going to arrow over to calc. Bless you. You will notice option 4 says lin reg ax plus b. Ax plus b looks familiar, doesn't it? Yeah. Mx plus b. Lin reg is the one you want. Option 4. It's going to say, okay, where's your x's, where's your y's? They should be by default, not necessary to change. Like, leave them alone. They should be right. Now, here's a little extra. When you hit enter, it's going to just spit out the numbers for you. If you want to see if the line they just gave you is accurate to the data you plotted, there is an extra feature where you can store the line of best fit into Y equals. And that would be these steps right here. You don't have to do this, but I like it because then I can just kind of check it. So here's what you do. Before you run through and just say calculate, you go down here to where you're telling it store reg EQ, meaning store the regression equation. Where do you want it to store it? You want it to store it in Y1, right? We'll say it again. You don't have to do this part. This is not the necessary must memorize part. This is an extra. How do you get to the Y1? You cannot just type Y1. I wish you could. You have to hit what's called vars, which stands for variables. It's this button right here. You're going to say variables. You'll see Y vars, meaning all the Y variables. You're going to arrow over. You want the function Y1. and hit enter, and it's going to type it there. I wish we could just type Y1, but we can't. And I think it's because it's a subscript 1, and that's why it won't recognize Y big 1. Then you hit calculate. Now watch what happens. There's your data. There's your answers. I think we went to the nearest 10. We went to the nearest 10. But the equation would be y equals 0.3x plus 2.8. Do you see that? Now watch if you told it to store it in y1, watch this. Just hit graph.
Whoa.
Because you told it to store it in y1. If you don't do that, it won't graph the line, which doesn't mean you get the wrong answer. It just means you don't have that nice little visual shooting through the data to let you know, oh, I did this right. Okay, and then look, watch this. If I go to y equals, that hideous equation is right there, all the way to the ugliest decimal. So you might want to make a note on your paper over here that this is extra. That line right there. You don't have to do that part, but that's a nice to know how if you want that visual confirmation. As far as what you actually have to know for the test, you have to know entering the data. You have to know this line here and this line here. You have to know that. I cannot tell you that during the test. That bars button is where you're telling the calculator to store the equation into, and you have to go to the bars button, which stands for variables, and select the function. Wait a minute, you didn't hit bars. So if you do stat count, lid drag, the arrow down here, and then now you hit bars. Arrow over Y bars, first one, and it's the first one. And then now you tell it to calculate. Alright, now the next thing I wanted to draw your attention to, this is kind of cool because I'm in quantitative statistics right now, and we just had a refresher on the basic correlation coefficient, and I'm like, oh, I'm about to do this with my students. Did you have your hand up? Okay. Correlation coefficient. Go to the next slide. Wait, what do you do after that? That's it.
That's the answer.
Well, your equation, if you want to go back, I thought you wrote it down, but we can go back here. So our equation was, we said y equals 0.3. Hold on. Y equals 0.3x. What was the other? 2.8. Now this is off a little bit. If you were to actually graph y equals 0.3x plus 2.8, you would see that it's not going to line up with the one you're on. The question did say estimate the cost of a 30-second commercial in 2018. What would x be in 2018? 8. So what do I do here?
You plug it 8.
But I wouldn't want to plug it into this one, right? Because this one's rounded. I would want to go here and plug it into that one. Or you could go to your table. You go to the table. Second table, and then at 8 it would be 5.4 million. Don't even get me started on that. I have a way more important job than Pepsi, and they make way more money. But anyways, so a 30-second commercial in 20, what was it? In 18 is 5.4 million. Yeah, wrap your mind around that.
Like when you pay.
Yeah, I want to make money, of course. That's it.
I'm about to shuffle
A
it.
stroke change. He makes that when he's asleep. Sometimes. I just make I make a difference.
Yep.
I don't make a living. I make a difference.
Wow.
Is that cheesy?
Yeah.
Okay.
Change it so outdoor.
No, not that bad. All right. So let me show you this because then we're done with 1-4. There's not really many notes to take because I put the pictures on here of all the scenarios. What's the point of a correlation coefficient? The point is to let you know how strong the data consistently lines up with the line you just found. So really, really, really strong lineup, meaning in this case, if R is 1, it's passing through every single point, and it has a positive slope. If R is -1, it's passing through every single point, and it has a negative slope. If R is near 0, look at both of these on the far right, these two right here. If R is near 0, there's a very weak correlation, meaning the line that they're giving you is not necessarily a good indicator of future values because it's all over the place. To give you a scale, it's right here. So, and let me actually move that to here. When it's 0, that means it's like all over the place, and the line of best fit can hardly go through any of them. It's just way too scattered. There's no consistency in the data. If it's strong positive, it's the equivalent of the line passing through every point with a positive slope. If it's strong negative, it's the equivalent of the line passing through every point with a negative slope. When you did your linear regression, your calculator produced the R value for you. It showed it to you. I don't remember what it said. Let me see if
It
I
was
can,
like R.09.
I can get there real quick. Oh, no, I can't. I just need a clear list. Son of a nutcracker. Hold on.
Son of a.
Oh, it's right here. It was 0.9929.
I was close.
The one from the data that we just did. So 0.9929 is really close to 1, which means it's passing through the majority of the points, and it has a positive slope. So is it a good predictor? Yes. Does that make sense? If R was near 0, you would not want to rely on the equation as a predictor. That's all of 1-4.